Hey everybody, and welcome back to Algebra 2 Online. Today we're going to talk about systems of equations and word problems, and they're really not different except that you have to unpack what the equation is before you can solve them. Before we do that, I just want to go over one more problem related to a system of inequality. So it's just good to see another example where we got some kind of weirder things maybe happening with the graph. So I'm going to do this in colors. So for most of these equations here, we don't really need to do too much in order to graph them, but I would simplify the first one a little bit. So if you divide by negative, you would get instead y greater than absolute value of x minus 1 plus 1. And that's the form that I would graph it in. And then the second one I like, third one's fine, and the fourth one's fine, really, because it's just point slope. So this first absolute value inequality here just has two shifts going on. We've got a shift right and a shift up. So its vertex is over at 1, 1. And there's no like stretching or compressing or flipping or anything. So it's just got like slopes of 1 or negative 1. It is dotted. Be careful about that part. And I think I'll wait to shade until the end here. So the next one is just a quadratic that's been shifted to the right 2. And it also doesn't have any stretching or compressing or flipping or anything. So this one's solid equal to 1, so we're going to just kind of draw that. And the next one is just a, if it was just x less than 2, it's just a vertical line at 2, and then we'd shade to the left. But we have this other boundary, so basically we kind of get two vertical lines. The one at negative 1 is solid, it's a horrible line, and then this one is dotted, and we're going to shade between there, but we'll wait to do that again. And the last one's just a line in point slope, right? The point is just going to be, the point is just negative 1, 2, and the slope is just 1. So we're going to plot the point negative 1, 2, and then it's got a slope of 1. So we got that, and it's a solid line here. That's a good line. Okay. So now for shading. So we shade above the absolute value. So that's going to be like in here. We shade above the quadratic, so in here. And we shade between the vertical blue lines, and then we're shading below the red one. So if you put that all together, basically we're kind of in, that's kind of not right because of the quadratic. So we would be in that sort of region right there. This kind of continues, and it's bounded on the left there by that quadratic, below by the absolute value, to the right by this dotted blue line, and then above by the red line. So the real goal for today is to just do these problems related to systems of equations, but with word problems. And really the main part that we need to talk about is how we get the equations out of them. And the way I do it is I basically, equations are sentences. So if you look at like a, any given sentence like this one, the number of 29-cent stamps is 10 less than the number of 32-cent stamps. That's it could have been a period right there. That should be like an equation, and then this one is also going to be an equation. And this one is also, oh wait, I guess that's it. This one's going to be an equation too. But you also need some sort of like structure. So it's good to know what you're trying to do. So in this question, we want to know how many of each stamp there is. And so if you take, if you see the first sentence, we say that there's 3 types of stamps. I'm going to call that one X. I'm going to call that one Y. And I'm going to call that one Z. And we now can like turn, like say this sentence into, or this complete statement, into an equation. So we know that the number of 29-cent stamps, which is Y, is 10 less than the number of 32. So the word is giving me an equal sign. And we know that it's 10 less than the number of 32. So you could take your 32, which is X. Actually, I'm going to keep this in blue. You could take your number of 32, which is X, and just subtract 10. It looks like a 16. And that would be the number of 29-cent stamps. So that would be the blue kind of equation. Then there's this part that says, while the number of 3-cent stamps is 5 less than the number of 29. So the number of 3-cent is Z, and it's 5 less than the number of 29. So that means whatever Y is, if you subtract 5 from it, you get the number of 3-cent. And this last part, let's do, trying to pick a color. Let's pick this. So we know that the total value of stamps is 9.45. So this is sort of going to be some sort of like money equals money equation. And the total value is just a mix of how many of those stamps were sold, multiplied by their price and then added together. So basically you know that 9.45, right, would equal 0.32 times however many of those stamps were sold, plus 0.29 times however many of those were sold, plus 0.03 times however many of those were sold. And then the problem basically just becomes a system of equations. These are your 3 equations. And if you ever have 3 equations, like ABC here, you should be able to solve for 3 unknowns like X, Y, and Z. I don't want to solve it out because this is just one of your homework problems, but I will say that I would personally do this with substitution. You could take Y here. It's already solved for, right? X minus 10 is Y. You could put it in there, and you could put it in there, and then you could solve a system that just has Z's and it'll have X's. So that's kind of how I would do it, but I want you to go through the actual computation of it. But this kind of unpacking is what you'll want to do on all those problems on the homework.